Come back. Here is example 2. Find the volume of the solid obtained by rotating about the x-axis the region under the curve y equals cube root of x from 0 to 8. What does that mean? Y equals cube root of x curve looks like something like this. When x is 0 and x is 8, you get these 2 points, 0, 0, and when x is 8, 8, 2. Cube root of 8 is 2. So you are looking at this curve from 0, 0 to 8, 2. So you are going to take this region under the curve and rotate it about the x-axis. So you take this and rotate it above x-axis. So here is the picture you get. You took that curve, that region under that curve, and rotated it, and you got a solid. Okay? You have to recognize it's not just the outer shell. You see, it's a solid, it's filled in. So the entire region under the curve is rotated about the x-axis and you get a filled in solid. So upon rotation about the x-axis, we obtain the following solid. Note, this solid is supported from 0, 0 to 8, 0. That's the center here. In other words, x coordinate goes from 0 to 8. All right. So this solid is supported from over the closed interval 0 to 8, and for each x in this closed interval 0 to 8, the cross section, that is when you take slices, vertical slices, the cross sectional circle has radius y coordinate cube root x. Okay, so look at this cross sectional circle. What's the radius of the circle? It's this vertical distance. That vertical distance is what we call y coordinate. What was the y coordinate? Well, y coordinate is determined by the curve. The curve is y is cube root x. So the y coordinate is cube root x. So that's your radius. Radius is cube root x. Each approximating cylinder, so that slice there, when you cut two, you basically are looking at each thin slice. Each slice is a cylinder of width delta x. Delta x because I'm supported on the x axis. And the base area, so this area here is pi radius squared, but radius, notice, was y coordinate. Pi cube root x squared, which is pi x to the power 2/3. That's the cross-sectional area. Once you have the cross-sectional area and the interval, you are set to define the volume, compute the volume. Volume of the solid of revolution is V is integral 0 to 8 because you are going on the x-axis from 0 to x. That's why you are taking integration with respect to x. Of the cross-sectional area, that is pi x to the 2/3. Cross-sectional area is pi x to the 2/3. So now that you have set up the problem, you can proceed. The integration of this is pi x to the 2/3 plus 1, that is 5/3, divided by 5/3. The limits of integration are 0 to 8. I just need to substitute 8 because substituting 0 gets me 0. All right. Substituting 8 for x. Power 5 to the power 5 over 3 means you are going to take cube root, third root, and then power 5. Third root of 8 is 2, power 5 is 32. So 3 times pi times 32 over 5. So that is 96 pi over 5 cube units. Leave the pi as it is because that's an exact value. So notice there are no approximations anymore. This is an exact value. So 96 pi over 5 cube units. So this is an example of solid of rotation. You take a region under a curve, rotate it about an axis, and you get a solid. Okay. Now let's look at the same region. Now you're going to the same region, but you're going to rotate it about the y-axis. So notice what's happening here. I'm going to take the region and rotate it about the y-axis. So I'll come to this example in the next video. Until then, bye.